Section 5.2, the real zeros of a polynomial function. The goal of this section is to factor polynomials of higher degree so that we can obtain the real zeros of the polynomial function. So back in section 5.1, we really started studying polynomial functions, and the goal of that section was to graph by hand a polynomial function of higher degree. And key to the graphing process is working with the zeros of your polynomial function, which is the same thing as the x-intercepts. And it was kind of straightforward in that section to get the x-intercepts or the zeros of your polynomial function because the polynomial function was given to us already factored. So all you had to do to get the zeros was take each factor, set it to 0, and solve, and boom, you had your x-intercepts. But now we're going to look at some situations where you're given a polynomial function of a higher degree and it's not factored. So it's going to be more difficult to obtain your zeros or x-intercepts. You're going to have to factor the polynomial to get your zeros. And the factoring techniques that you may have learned in the past may not work. Okay, so we're going to talk about the process you would go through to factor your polynomial function of a higher degree. Okay, if you take a look at the second bullet point here, it says this process is going to involve the use of synthetic division. Okay, it may, in some situations, we may have to use long division. Okay, if you don't recall how to do synthetic division or long division of polynomials, not to worry, I will walk you through it. Okay. Before we jump into this whole process, I'm going to review the division of integers, okay, that just means just numbers, to kind of understand why division is important to factoring, okay? So I'm going to give you two illustrations of just doing division with numbers, okay, because there will be some key takeaways from this that will also apply to the division of polynomials, okay? In illustration 1, let's try to take 453 and divide it by 3. Okay, so we're trying to figure out how many times does 3 go into 453. Okay, so let's remember how to do this. This is the process of long division, but like I said, we're mostly going to use synthetic division when we're working with polynomials. So just hang tight. I'll show you how to do that. Okay. All right, so here we go. What you would do here, okay, is you're going to first look at the 4. Okay, you're going to say, how many times does 3 go into 4? Well, 1 time. Okay, 1 times 3 is 3. So we're going to take the 3 and write it here. We're going to subtract that. 4 minus 3 is going to give us 1. And we're going to bring down the next number. So that's going to give us 15. So now we ask ourselves, how many times does 3 go into 15? Well, the answer is 5, because if we do 5 times 3, that's going to give us 15. So we need to subtract that out. That's going to give us 0, but we still have a number to bring down. Okay, so we're left with 3 down here. So I'm going to go ahead and erase the 0 because we don't need it. Okay, so now we're saying, how many times does 3 go into 3? Well, once. 1 times 3 is 3. So I'm going to subtract that out, and I'm done. I have a 0 remainder. There is no other number to bring down, so we are done. Okay, so what you should realize here, okay, 3 divides evenly into 453 because we got a 0 remainder. Okay, so I'm going to make some notes over here. Okay, so 3 divides evenly into 453 because we got a 0 remainder. Okay, so it divides exactly 151 times. Okay, we can kind of translate this whole division process. If we take 3 and multiply it by what we got, the answer we got, 151, that's going to give us 453. Okay, we're just kind of rewriting this division process as a multiplication process. Okay, All right, so it's key here that you understand that when you're doing division, if you get a 0 remainder, then the number you're dividing, it divides evenly into the number that you're dividing into, okay? All right, so we're going to take a look at illustration number 2 in just a second. But since we're going to be working so much with division, I want to make sure you know the terminology that is involved, okay? So we're all pretty familiar with remainder, okay? But some of these other terms you may not know. The number that's being divided into, the 453 here, it has a name. It's called the dividend. Okay, so dividend. And then 3 is the number that, is being divided into 453. It also has a name. It's called the divisor. And then you get a result. The result of the division is 151. That is called the quotient. Okay, so now that we've got, these terms associated with this, if you end up with a 0 remainder, that means the divisor divides evenly into the dividend, okay? All right, so let's take a look at illustration number 2. Okay, I'm going to change this very slightly. I'm going to keep the dividend the same, but I'm going to change the divisor. Okay, so let's divide 453 now by 4. Okay, so it's going to be the same kind of process. I'm going to start by saying how many times does 4 go into 4? 1 time, 1 times 4 is 4, so we've got to subtract that out. That's going to be 0, so we can just bring down the 5. So now 4 goes into 5 1 time. 1 times 4 is 4, so subtract that out. We're going to get a 1, okay, and we have one more number to bring down. So now we're asking ourselves, how many times does 4 go into 13? Well, 3 times. 3 times 4 is 12, so subtract that out, and you're going to be left with 1. But there's no more numbers to bring down, so we're done. Okay, so here we ended up with 1 as the remainder. Okay, so what happens here, since we did not get a 0 remainder, 4 does not divide evenly into 453. Okay, it goes into it 113 whole times, but then some. Okay, so I'm going to write this here. 4 does not divide evenly into 453 because we got a non-zero remainder. Okay, we can still summarize this process, okay, in terms of multiplication, okay. To get 453 here, okay, you can take 4, multiply it by the quotient of 113, and then add the remainder, okay? And you can see that on a calculator. If I do the divisor times the quotient and add the remainder, I get the dividend, okay? And that is always true, whether you're working with numbers or polynomials, okay? So that's something to remember. So I'm going to actually write that down in the box. Again, if you're working with just numbers or if you're working with polynomials, to get the dividend, which is basically the number, or it'll be a polynomial later, underneath the division sign, okay, you're going to take the divisor, multiply it by the quotient, okay, and then add the remainder. Okay, that's always going to be true. Okay, so you might be wondering, okay, what was the purpose of me showing you the division of numbers if we're going to be doing the division of polynomials? Okay, well, underneath the box here, there are 2 important statements I need you to remember. Okay, this first statement is basically illustrated in illustration number 1, and the second statement is shown in illustration number 2. Okay, so let's take a look at this first statement. It says if you're dividing, okay, and if a 0 remainder results, then the divisor divides evenly into the dividend, and the divisor is a factor of the dividend. Okay, so let's go back up and look at example or illustration 1. Okay, We divided 3 into 453. We got a 0 remainder, so that means 3 divided evenly into 453. And so another way we can think of that is that 3 is a factor of 453. Okay? If you made a factor tree, 453 can be broken down into 3 times 151. Okay? So because 3 divided evenly into 453, 3 is a factor of 453. Okay? If you look at the second statement here, okay, if you're dividing and you do not get a 0 remainder, then the divisor does not divide evenly into the dividend, and the divisor is not a factor of the dividend. Okay? So if we look at the second example where we divided 4 into 453, we ended up with 1 as the remainder, a non-zero remainder. So 4 does not divide evenly into 453. So another conclusion we can make is 4 is not a factor of 453. Okay, meaning you cannot write 453 as 4 times something. It's not going to work. Okay, so these are really important statements at the bottom. Okay, you need to know them. Okay, you will see this exhibited when we start dividing polynomials, and it will be very helpful in factoring our polynomials.